Welcome back to Explaining Everything, the channel where we dive into the stories and mysteries behind everyday things. Today's question comes from one of our curious viewer, Wired and Weird 101. Thanks for the suggestion, Wired and Weird. You asked, why do power lines sag instead of being tight? We're surrounded by these things, yet nobody ever stops and goes, huh, that wire looks exhausted. You'd think something carrying electricity would be pulled taut, but instead, it's just drooping there. So, is this a flaw? Or is that slack on purpose? Let's plug into the answer without electrocuting ourselves, right here on Explaining Everything. Here's the big secret. That sag? It's not an accident. It's by design. Engineers want those wires to hang a little loose. If a power line were pulled completely tight, it would be at risk of breaking, especially when temperatures change or the wire gets weighed down by wind, ice, or just the sheer heat of all that electricity zooming through it. Tight wires under stress are basically time bombs. Instead, that droop gives them breathing room. When things heat up, metal expands. That expansion needs space. Otherwise, the wire stretches, warps, or worst case, snaps, and nobody wants surprise fireworks from the sky. So sag is not sloppiness. It's stress management. Let's talk materials. Power lines are usually made of aluminum or copper, sometimes with a steel core. All of these expand when hot and contract when cold. In the summer, that expansion makes wires longer. In the winter, they shrink back. So imagine what would happen if the wires were stretched super tight during installation. Come summer, they expand, and suddenly they're tighter than your jeans after Thanksgiving dinner. By giving the wire room to move, engineers keep things safe. That sag is like the wire's stretchy pants. It adapts. Fun fact, in cold weather, those wires can actually look tighter. So if you've ever looked up in winter and thought, that wire got a makeover. Nope, that's just physics doing its seasonal fashion rotation. Let's get a little geeky. The shape of a sagging power line isn't random. It follows a mathematical pattern called a catenary curve. This is the same curve a rope forms when you hold both ends loosely. It's not a U, not a V, but a special kind of curve that balances the weight and tension in the most natural way. Suspension bridges, like the Golden Gate. Same principle, except they flip the curve with cables. So when you see power lines sagging, they're not being lazy. They're just following the rules of physics to find their most stable, efficient shape. It's the universe's version of just vibing. Let's pretend we said nah to all of that and yanked those wires super tight anyway. What happens? Disaster. Tight wires don't handle expansion well. So when summer heat hits or wind starts pushing, the wire gets stressed. Stress leads to tiny cracks. Cracks lead to breaks. Breaks lead to outages, danger, and extremely grumpy utility workers. And if a line does snap, you're looking at a very expensive, very dangerous situation involving a metal whip of electricity flailing around like it's trying to start a fight. So yeah, engineers learned a long time ago, better to sag now than snap later. Could we use materials that don't stretch or sag as much? In theory, yes, but in reality, it's not that simple. The materials that are more rigid tend to be worse at conducting electricity, heavier to hang, and way more expensive. Power lines are all about balance. Engineers need something light enough to span long distances, good at conducting electricity, and flexible enough to handle changing conditions. And the combo that checks all those boxes: aluminum, copper, and yes, a bit of sag. So while future materials might reduce droop, for now, it's the best compromise. Practicality wins over perfection. We tend to think that tight means strong. But in engineering, built-in flexibility is often what saves the day. That sag you see in power lines isn't a sign of wear, weakness, or laziness. It's a carefully calculated safety feature, one that lets the line breathe, bend, and bounce with the elements instead of breaking from them. In fact, engineers use specific formulas to calculate exactly how much sag each line should have. They factor in tension, temperature range, the weight of the wire, wind load, even how much ice might collect on it in winter. So yeah, it's not just droop, it's data-driven droop. Next time you walk under a sagging wire, don't judge it, respect it. That line is out there handling wild temperature swings, brutal wind gusts, and thousands of volts of electricity, all without cracking under pressure. And frankly, that's more than most of us manage before noon. If you learned something new, don't forget to like, subscribe, and maybe give a little wave to the power lines above you. They're doing a lot more than just hanging around. And hey, if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about, here on Explaining Everything.